All right, question 31. Quantity of water contains 700 grams of pollutants each time the water passes through a filter. 18% of the pollutants are removed. So the nearest tenth of the gram, calculate the mass of the pollutants remaining in the water after it passes through the 7 filters. Okay, well, to start off with, A, we're taking a look at the number of pollutants in there. We got 700 grams of pollutants. Now, R is going to be related to that 18%. Now, this is worded in kind of a weird way. 18% of the pollutants are removed. We're losing 18% of them. We don't have 18% left. We're losing it. So when you lose 18%, just think of it like an exam. If you had an exam, okay, you could obviously the maximum you can get is 100%. So if you lost 18% worth of marks, what did you get? Well, you were left with 82% or 0.82 as a common ratio. So now our general term is going to be 700, okay, times 0.82 to the n minus 1. Now in this case right here, once again, we got to be a little bit careful with the value of n. As if you're thinking back to that previous question, question 30 here. So here's the water, okay, here's the water coming in, so it's got all of it, so 700, then it passes through 1 filter, 2 filters, 3 filters, 4 filters, 5 filters, 6 filters, 7 filters to come out at the end. Okay, so we're trying to figure out how many pollutants there are in here. So here's the first term. Basically, how many times are we going through this? Well, what term is this? 1, 2, 3, 4, 5, 6, 7, 8. That seventh filter represents the 8th term in this sequence. Okay, because that first one there, where it hasn't gone through the filter yet, that's 700. We've called that our first term here. So we are looking for T sub 8 equals 700 times 0.82 to the 8 minus 1. And so now this is just calculator work here. So 700 times 0.82 to the power of 7. And we get 174.5 grams of pollutants left in the water.